Let's talk about a huge challenge that faces pretty much every technical professional today. The thing is, real success isn't just about what you know how to build. Nope. It's also about being able to navigate the crazy, complex, and let's be honest, often frustrating systems you have to deal with just to get your job done. This is a universal struggle, whether you're an engineer, a doctor, or a software developer.
And that brings us to the big question we're tackling in this explainer. To really make it, do you need to be a brilliant engineer or a master bureaucrat? The source material we're digging into suggests the answer is, well, it's both. It's this dual identity that so many of us have to wrestle with every single day.
And this right here, this just captures those two worlds perfectly. On one side, you have technical mastery, a world of logic, physics, pure precision. It's where you're solving problems with calculus and building systems that actually work. But then, on the other side, you have bureaucratic resilience. This is a world of paperwork, endless processes, and compliance, where you're just trying to navigate systems that, frankly, feel completely broken. Let's start with that first world, technical mastery.
Okay, so let's dive into this first challenge, climbing what we're calling the technical mountain. This is all about the incredible, intense, intellectual dedication it takes just to get in the game in a field like engineering.
Take something like Boolean algebra. It might sound really abstract, but this system of logic is the absolute foundation, the bedrock of all digital circuits. It's literally how engineers take these unbelievably complex systems and simplify them, how they find faults, and how they design the automated world we all live in. This isn't just about memorizing facts, it's a whole different way of thinking. And believe me, it doesn't stop there. The core demands are intense. We're talking advanced calculus, AC/DC circuit theory, control systems, digital logic. Each one of these is a massive field of study on its own, and mastering them takes years of really focused, rigorous work.
A single formula like this one can really capture that whole world of precision. You don't have to be a math whiz to see the elegance here. This equation uses integral calculus to figure out the total energy lost in a resistor. It's a perfect example of the hard science that underpins all of this work. But here's the thing. That's only half the battle.
So, let's flip to the other side of the coin. After you've mastered all that technical complexity, you step into a whole new arena, the bureaucratic maze. And this is a struggle against systems that just do not work as logically as a circuit. Not even close.
For the professionals in South Africa, where this source material comes from, this is the daily reality. But I bet this web of oversight feels familiar to anyone in a regulated industry, anywhere. It's not just one system, it's multiple, overlapping bodies, SAQA, the DHET, QCTO, various SETAs, all creating more and more layers of administrative work.
So what's the result of all this complexity? Well, the source material puts it pretty bluntly. The system is often, and I'm quoting here, plagued by delays, irregularities, and bureaucratic failures. This is the kind of friction that can grind the progress of even the most brilliant person to a complete halt. And look, this isn't just some abstract complaint. The source gives a very real, very concrete example. There were major irregularities in an electrical theory exam back in 2021, and the outcome? The results were invalidated, creating huge backlogs for students and professionals who had done everything right. This is where technical skill smacks right into systemic failure.
So, you've got this mountain of technical skill on one side, and this maze of bureaucracy on the other. How on earth you bridge that gap? Well, the source proposes a pretty smart solution, building an integrated framework.
The whole idea rests on four main pillars. First, standardizing qualifications so they meet both national and international benchmarks. Second, making credentialing more inclusive to open up access for more people. Third, actually integrating the different systems for trades, engineering, and education so they talk to each other. And fourth, and this is the absolute key, creating what's called audit-ready documentation.
This really comes down to turning your entire career into a portfolio of evidence, and this table shows exactly how that works. You don't just say you can find a fault on a circuit, you show it, by linking that skill to a specific standard and providing real evidence, like a logbook entry with photos. You don't just claim you can design a circuit, you provide the CAD file as proof, you see?
And what's the outcome of this approach? You create what the source calls the resilient professional, someone who isn't just skilled, but is totally prepared for the realities of a modern global career.
The advantages really start to stack up. Suddenly, your qualifications are instantly verifiable, which employers love. You get broader career access, and your skills are actually proven to bridge theory and practice. At the end of the day, it means your career is built on solid proof, not just a bunch of claims on a resume.
This right here is the formula for success in this dual challenge world. You take audit-ready documentation, you add standardized qualifications, and you combine it with accessible methods. And what do you get? You get resilient professionals who can adapt and thrive, no matter where they are in the world.
So, we'll leave you with this final question, and it's a big one to think about for your own career. In this world of ever-increasing complexity, are you building a simple resume, which is just a list of claims? Or are you building a robust portfolio of evidence, a collection of undeniable proof? Thanks for watching.